Hi class, so today we'll be discussing reaction time. Hi class, so today we'll be going over reaction time, movement time, Hick-Hyman law, and Fitt's law. So reaction time and movement time can best be thought of as input and output. For example, if someone throws a ball at you, which we just demonstrated, you best hope you see the ball. If not, you get a ball in the face. Input correlates to your five senses, which this ball would be part of it because it's going to be the external part. So this ball coming at me and my eyes witnessing it will be part of the five senses. This input goes through your high centers, which is part of your nervous system. There's three phases of that part. So there's the stimulus fortification, and then there's response selection, and lastly, response programming. So whatever physical action it is that you perform, that will be called the output. So going through the three phases, the last one is programming, which will tell you your body and the muscle group to move, and then the output is going to be the actual movement. So to sum it up, reaction time is going to be the input, taking in the stimulus, going through the three stages, and then the output is going to be the movement time, which is the actual physical movements, which is what you visibly see. So reaction time is best defined as the time from the initiation of stimulus to the initiation of a response to the stimulus, as we already went over with the ball and actually seeing it to catching it. So far I've demonstrated what is called the simple reaction time, which means it's going to be one stimulus alternative response and then my actual response to that. And then there's also choice reaction time, which would be multiple stimulus reactions, response time reactions. So to demonstrate choice reaction time, so as we saw, this time two balls were thrown at me. Reaction time was me taking it in, not quick enough to distinguish two of them and missing one of them. So that goes into choice reaction time. And then that brings us into the Hick-Hyman law, which explains that phenomenon in quantitative terms. William Edmund Hick and Ray Hick-Hyman provided similar data corresponding to this phenomenon nearly only a year apart from each other. Thus, which is why the law is named actually after both of them. They both got credit in that. They both claim that as the number of stimulus response alternatives increase, a rise in uncertainty will cause an increase in reaction time, which means by increase in reaction time means it's going to be slower on my part. Their experience showed that reaction time increased by nearly a constant number every time the number of stimulus response alternatives doubled, which this formula gives proof to that.
Go. Go.
Now, as the Hick-Hyman law went over and tied in with reaction time, giving us simple reaction time and choice reaction time, we have Fitt's law that expands on movement time, or the output process. Now, just to redefine movement time is best defined as the time from the initiation of a movement until its completion. Fitts' law, which was proposed by Paul Morris Fitts in 1954, established a quantitative relationship between speed and accuracy of movements. So movement time equals A plus B. So A stands for the distance traveled, and W is going to be for width of the target area. And then the 2A is going to stand for the index of difficulty. Movement time is directly to distance traveled. So using this as an example, if we had the start line here, so two competitors will start at the same distance, but their destinations will be at different distances, which will affect their movement time. As is, if they are running at the same speed, this one should be getting to the ball quicker than the one that has to go further the distance. Movement time is also inversely related to target width, which the higher the accuracy is required in the action, an increase in movement time will be found, which means it'll take less time. So in this example, we have a ball traveling at the same distance, but its target destination will either be bigger or smaller, which the one that's bigger, less movement time is required because less accuracy is required. So it's going to be easier to make it in, so they can throw a straight shot right in there at a faster speed. An increase in movement time because more accuracy is required. So it should take more time to prepare the shot. It could be a slower throw, just because they want to aim certain angles to make sure it gets into that goal, which is almost the size of the ball. And then we have index of difficulty, which an increase in difficulty will increase movement time. So the harder the objective is, the more time that will come with it to complete it. A decrease in difficulty will decrease movement time. As in, going back to the goal, it's a much bigger goal, which means less accuracy, which means it should be easier to make it in there and should take less time. Reaction time and movement time can both be changed through training. Going with back to movement time, accuracy and speed can both be augmented through training. Going back to the goals, even though they're different sizes, if someone did train, they could throw into the smaller goal at the same movement time as the bigger goal through training and an increase in accuracy. Same thing going with reaction time. Someone that is training for certain sounds or certain sensations, or if they already know something's going to be coming, there will be a quicker reaction time because they've already have a potential plan thought out, or they already know what to do when they hear or see that thing. And to sum it up, leading into what I'm going to be demonstrating, for Fitts' law, the claim is, and as it's shown through the formula that you can mathematically prove, you essentially have to trade speed for accuracy, which demonstrated in that, and I will be demonstrating in just a moment. Demonstrating how movement time is inversely related to target width. An increase in target width will decrease movement time, which means it should be quicker movement time. The index of difficulty means an increase in difficulty will increase movement time, which means it'll go slower depending on the difficulty. So starting off on an easy difficulty right now, I have a decent sized round ball. So now moving from a bigger ball to now a more medium ball, but keeping in the same hoop, which even though the ball is now shrinking, that means the index difficulty is actually going to go down. The bigger ball will actually make it harder because the hole is only so big. So the smaller the ball now and the bigger the hole, it's going to be easier to make it in. Going even smaller for the ball, keeping the same size of the hoop, even easier. So now the index of difficulty is actually going to change. It's going to become easier now with the bigger the ball, because now this is what we're going to be targeting. Now the ball is as small as we got with the net, which is going to actually make it even harder now. And it's gone. And lastly, I'm going to demonstrate that distance will affect the movement time as well. By having where me and my companion here, we're going to be running towards two balls at different distances from each other, which will show the distance in the movement time between me and his action.